In this video, we will learn about limits at infinity. I have a little cheat sheet right here on top, but before we start working it out, I want you to think about a couple things. So what does all of this mean? So let's say that infinity is a really large number. So like for the first example, if I am to replace x with a very large number, whatever that is, just think about what happens to this fraction right here. So if you're dividing 1 by any large number, what's going to happen to that number? That number is going to be really close to 0. So it's going to approach 0. So, and as you're working this out, just think about replacing the variable with a very large number. Or when you get to, instead of dividing and then we're multiplying, a very large number and you're making it exponentially larger, what's going to happen to that number? Is it going to shrink down to nothing, or is it going to expand to, the largest number you've ever thought in your life? So as we're working on limits at infinity, I just want you to keep that in mind. And then, of course, I'm going to show you a few tricks just to get the right answer. And you're going to have to show your work one way or another. And I will give you a couple of options there. So here we have cheat sheet. And be careful that this one right here on top, they're approaching positive infinity. And these two, they're approaching negative infinity. And here you have something else for you to take into consideration. So let's go ahead and start taking care of this. So here I have 1 over 10x. So I know if I can split this up to where I have 1 over x, I know that I will be able to approach that my answer will be 0, either from approaching positive infinity or approaching negative infinity. So the first thing I'm going to do here, I'm going to split that up in 2 limits. So I have limit as x approaches infinity of 1 over 10, and we know how to calculate that. And then also multiply by the limit as x approaches infinity of 1 over x. The limit of a constant is the constant, so I know that at this point it's 1 over 10. And here I know that the limit as x approaches infinity of 1 over x, so that's what we call bottom heavy. So if we're dividing by a large number, we know this will approach 0, will be really tiny, close to 0. So that's, you're going to eventually memorize this. So this is 0, anything multiplied by 0, voila, 0. So it's easier than it looks. But just be careful when you're practicing, you can easily get the right answer. But just keep in mind how you're going to prove that that's the right answer. Just prove your thought. Okay, so this one I'm going to take the same approach as number 1. So I will split this up in 2 limits as x approaches infinity of -4 times the limit as x approaches infinity of x. Again, the limit of a constant is the constant. And then the limit as x approaches infinity of x, that'll be infinity. Now, here's the trick to this one. -4 times infinity, what does that mean? So the trick here, you're going to check out the signs. If the signs are the same, then you're going to end up with positive infinity. If the signs are different, you're going to end up with negative infinity. So if you want to write yourself a little note right there. So different signs, then negative infinity. So if this doesn't mean anything to you, so go ahead and write it out. Another one, we have, I will again split that up in 2. So the limit as x approaches infinity of 9 times the limit as x approaches infinity of x cubed. So this one is easy. The limit of a constant is the constant. And then here, I just have that right there. It's just positive infinity. There's no thought about it. So positive infinity right there. Compare the signs. They're both positives. So positive infinity. So same sign. It's positive infinity.